Howdy, AP PreCal. It is Miss Kosh. This is the second day of notes for my this new year. It's mostly section 1.3, but then I realized that I think I kind of swirled 1.1, 1.2, and 3 all together and broke it into 2 different days. So this first part is a warm-up, and it kind of generates our next ideas and kind of gets us going. So I found the average rate of change between the points that it told me. So I was looking at these different values. I took the y value minus y minus y over x minus x, and I got these numbers here. Okay, so I don't, if that is a problem for you, then go back and watch my previous videos. Okay, so moving forward, what do we notice? We notice that these, so if you think about -2.5, -1.5, -1/2, +1/2, 1.5, 2.5, 3.5, my numbers here are increasing. Okay, so the average rate of change is increasing over this whole interval, and that is going to lead me to the fact that it's concave up. Okay, we used to always say that this is concave up like a cup, which is great, and yes, you can see the concavity in the graph, but the way that AP is going to ask you to verify that something is concave up is to show that the average rate of change is increasing. Okay. Then the next one, we had these values for the average rate of change. It's 5, 3, 1, -1, -3, -5, -7. And you may notice that those are all decreasing. Okay, and so the average rate of change is decreasing, which is what AP is going to ask you. Because they're decreasing, that's how we know it's concave down. Or because we see that it's concave down, the average rate of change should be decreasing. And it is. These numbers are getting, now it can be a little confusing because the absolute value of -7 is bigger than this 5, but we're not asking about the absolute value. We're not talking about how steep the line is. We're talking about, you're better off if you have $5 than if you owe me 7. Okay, so 5 is a greater value than -7. And so another way to think about this, the steepness of this was, it's getting less steep. It's very steep here. It gets less steep. It has a slope of 0, and then it kind of comes back down, and it's more steep, but it's more steep in the negative direction. So that is its average rate of change is decreasing over that interval. Okay, the other thing that we need to look at on these is that what did we do to go from -2.5 to -1.5? We added 1. What did we do here? Well, we added 1. This whole way down, we're adding 1 each time. What did we do here? We subtracted 2, and then we subtract 2, we subtract 2, we subtract 2, we subtract 2. So on all of these, this was our average rate of change, but the average rate of change is changing. Okay, so the rate of change of the average rate of change is constant, which tells me that it's quadratic. Okay. So that's what this is telling us. What do we notice about the average rate? What do we notice about the rate? The average rate of change is changing. So in the 2 examples above, well, they were changing at a constant rate. What does that tell us about the function? It tells us that those functions are quadratic. Okay. I think I have another example. Yes. Okay. Stick around. I'm going to show you a little bit better when it's on a table what we're talking about, but we're not quite there yet. Okay. So what does it tell us about this function? Since if the average rate of change was constant, notice it's not. These were different numbers. If the average rate of change were constant, it would be linear. You'd have the same slope over the whole line the whole time. It's linear. But since the average rate of change was changing is constant, it's quadratic. Oh my goodness. Okay, we're going to clarify this as we keep going. Okay, let's keep going in the order of my worksheet. On this one, so they're telling us we've got this function that's defined. I really should have put arrows. It was not anyway, I didn't do it, so there we go. Okay, it's defined on the interval -infinity to infinity and is given below. The point P has an x-coordinate of P. Okay, so I've labeled it point P, but we're saying that x, at this point, x equals P. And likewise, x equals Q here and x equals R there. Okay, so F has a local, or we could say a local or a relative maximum. So notice this goes off to infinity. It has no absolute maximum, but it does have a local maximum at P. It has a local or relative, I use those words interchangeably, maximum at the point R. And this is the inflection point where it changes concavity. So you'll notice it's concave down and then it's concave up. And that is at point Q. Okay. This is my day to talk a whole lot, y'all, so here we go. It's first day of school. F is increasing on the interval. Well, it was increasing until it got to P. So from negative infinity to P, but then it decreases. Okay, so from P to R, and then it increases. So we'd say union R to infinity. F is concave up. Well, this side is concave up, so from Q to infinity. And it's concave down on negative infinity to Q. I tend to use soft brackets for all of these. And every year we argue about would it be a soft bracket or a hard bracket. Good people disagree. So anyway, my style is just to put soft brackets, but I think AP would take either. Okay, the average rate of change is positive or negative on the interval negative. Okay, so let's look at this. So from negative infinity to P. So we're looking at this piece of the graph. The average rate of change is, so the curve here is increasing, which means that the slope of this tangent line would be positive. Do you see how we've got positive slopes there? So the average rate of change is going to be positive from negative infinity to P. The average rate of change, so from P to R, our graph is decreasing, okay, and so the average rate of change will be negative. The average rate of change, so from R to infinity, is going to be positive because it's increasing again. Okay, now let's look at this. F is increasing or decreasing, we're going to choose in a second, at an increasing or decreasing rate. Okay, so if you remember before, when it's concave down, it's increasing at when it's concave down, the average rate of change is decreasing. When it's concave up, the average rate of change is increasing. So where are we? So from negative infinity to P, we are concave down and increasing. So we are increasing, but concave down tells me it's at a decreasing rate. Okay, so the tangent line down here is going to be a larger value. Excuse me, let me try that again. The slope of the tangent line, the average rate down here is going to be bigger than the average rate of change up here. So it is decreasing. This could have a slope. Well, let's look back to nope, where'd it go? Let's look back to this one. This slope was 5 between those two, and then it became 3. So that was decreasing. Okay, what's happening from P to Q? From P to Q, our average rate of change is decreasing because we're going down, but it's decreasing, and it's concave down, so it's getting, the slope is getting more negative, which is decreasing. You're going more in the hole. We have our federal debt is getting bigger and bigger and bigger. That's bad. So we are decreasing at a decreasing rate because we are concave down, so it's at a decreasing rate, and the curve is going down, so the average rate of change is decreasing. Okay, so from Q to R, our rate is still, our curve is still going down. Okay, so but now we're concave up. So we are decreasing at an increasing rate. So our slope is becoming less negative. It gets here to where it has a slope of 0. So less negative means if you are less negative than you were before, your value is increasing. I think that's a good life lesson. Comment below if you thought that was funny. Okay, but like if you're, never mind, I lost my, okay. The next one, so from R to infinity, what are we doing? We're increasing, and it's concave up, so we're increasing at an increasing rate. Okay, the next one, let me see if I can find a different color. I forgot to plan ahead. Okay, now they're telling us we've got 2 more points. We've got the point A and the point B, and we are putting A somewhere on between, so A is over here between P and Q, and B is somewhere, it doesn't really matter where, between Q and R. So that's what we're telling you here. And the point A has an x-coordinate of A, point B has an x-coordinate of B, just like the P's and Q's and R's did. Okay, so now they're saying, what happens with the average rate of change on the interval P to A compared to the average rate of change on the interval A to Q? Okay, well, so in this area right here, the average rate of change is concave down, the average rate of change is decreasing. So this average rate of change is going to be bigger than this average rate of change. So PA is going to be, the average rate of change on the interval PA is greater than the average rate of change on the interval A to Q. Because this whole time, anything that came, it's decreasing. So this one is bigger than this average rate of change. These are going to take a little practice because they take a little bit to wrap your head around. Okay, so now we're looking at the interval QB versus BR. Okay, QB, so this one, our average rate of change is now increasing. This is a negative average rate of change, and this is a negative average rate of change, but this negative here is less negative than that negative. So the average rate of change on the interval QB is less than the average rate of change on the interval BR. Okay. Let's see. I'll finish this page and then make another video for that one. Okay, here we go. Let f of x be this graph right here. Isn't it lovely? Okay, so they're telling us we have extrema found here. So this one and C are extrema. And then B is the inflection point. So I think I tell you that. And just like a minute ago, the point A has an x value of A. The point B, it has an x value of B, but it also has an x value where x equals 0. So I would, if you could use that if you wanted to, I don't really care. Anyway, and then C, etc. Okay, so F is positive or negative on the interval negative infinity to negative 2. So you'll notice the values of F are negative. They are below the x-axis. Every y value on this interval from negative infinity to negative 2 is negative. What happens between negative 2 and positive 4? It's still negative. By the way, is it negative at negative 2? No, it is 0, which is neither positive nor negative. Okay, F is, and then what happens from 4 to infinity? The function will now be positive. Okay, so let's see how we do here. Find the intervals where f is negative, okay, so somewhere below the x-axis, and the average rate of change is positive, so it needs to be increasing. So we're going to say increasing, and when the graph will be increasing when the average rate of change is positive, and the average rate of change is positive and decreasing. Decreasing means it's concave down. So we want to be going up, but concave down. So we're concave down here, and we're increasing, so this is going to go from negative infinity to negative 2. Okay, let's switch colors. The next one where it's negative, okay, so still below the x-axis, and the average rate of change is positive. So positive means increasing again, and increasing means concave up. Okay, so we want to be increasing, and we're concave up here. And so we need to go from the C to, we have to stop at 4 because it needs to stay negative. So this is going to go from C to 4. Okay. The interval where f is negative, so we're still below the x-axis, and the average rate of change is negative. So now our graph is decreasing and increasing. Okay, so decreasing and concave, increasing means concave up. So decreasing going down. Okay, so notice we're decreasing all through here, but we're concave up from B to C. So you could tell me B to C, but we also said that B was equal to 0. So 0 to C, I think that would be a reasonable answer. Okay. Switch colors. The interval for where f is negative, so still below the x-axis, the average rate of change is negative, so the average rate of change is decreasing. Decreasing means it's going to be concave down, so we want to be going down where we're concave down over here. So that's from negative 2. You could tell me negative 2 to 0, or you could tell me negative 2 to that point B. That would be great. Okay, the last one, find the intervals where f is positive. Okay, well, our only option is here. So, and the average rate of, so let's see, the average rate of change is positive, so it's increasing. Yes, it's increasing. And increasing, it's concave up. Yes, it's concave up. So, sure enough, it's 4 to, not 0, 4 to infinity. Okay, so now what's happening? We've got a, they want us to put the average rates of change. I saw something similar on AP Classroom, and so I tried to write my own version, and I'm not sure I did as good of a job as what we've seen on AP Classroom. But they'll talk about the average rate of change at a particular point. Is it greater than or less than other points? Well, so what's happening here is the average rate of change is, I think I was wrong on my answer key. The average rate of change is decreasing, and then it starts increasing. So I think its smallest value is B. And then is that right? Yeah, because it's going to be steeper at B than it is at A, but negative. Okay, then A comes next. C has an average rate of change of 0. And then, so these two are both, their average rate of change were both negative, but it was decreasing. So the one that's, I need to go back and change my answer key. B should be the smallest value, then A, and then it's C, and then it starts increasing at D, and then E is going to be the biggest value. Okay, like, subscribe, comment, all the things. Pass this on to your friends. I hope to be making lots and lots of videos as this year continues. And go practice.